Hi everybody, welcome to Algebra 1. Today we are looking at Saxon Algebra 1. So I want to make sure that everyone's book looks like this. So we're doing Saxon Algebra 1. And today we're taking a look at lessons 109 to 112. And this is our third edition. So I want to make sure everybody who's joining us has the right book, the right page. So welcome. We're jumping in today at lesson 109. I'm really excited because some of the concepts we're covering today are so fundamental to algebra, and they're also some of my favorite. I absolutely love factoring. A lot of my students often tease that factoring to me is just the be-all, end-all for Algebra 1. So I hope you like factoring as much at home as I do. And some of my students might tease that they don't know anybody who likes factoring as much as I do. But I do hope that you understand that in Algebra 1, factoring is crucial and it will follow you into upper level math. So it's extremely important that you take time to understand how factoring works and how you can break apart those pieces. Factoring is just a way to think through multiplication and the process thereof. Of if I have this number and this number, how do they work together? So I hope that maybe you might feel a little bit overwhelmed, especially in the Algebra 1 level. Factoring can be something, the more that you do, the more confident you'll feel with it. So I hope at home that factoring is something that you practice often. And I am very thankful for Saxon Math because they take time to do that repetition and that review. So I hope at home you're taking time to do that review. So let's talk a little bit about basic factoring, because today we get into even more fun because it's advanced trinomial factoring. So if you would, begin with me on lesson 109, and we're opening to page 458 in our Saxon book. So advanced factoring. Now let's talk a little bit about the basics of regular factoring before we jump into, again, the advanced. All right, so lesson 109, it jumps right into your practice problems and how to do those. So before we do that, I'm going to talk to you just a little bit about basic factoring. So if I've got x squared plus 5x plus 6. All right, let's talk about just basic factoring. All right, excuse me while I turn this just a little bit to make sure that you're able to see my screen. All right, so one thing I want to point out to you in factoring is my leading coefficient should always be positive, and then after that, I always want to check and make sure that there's nothing in common, because if there is something in common, excuse me, my Sadie wanted to join us. Hold on just a moment. All right, I apologize. My dog saw some neighbors walking, so she wanted to join in on this video, so I apologize. All right, so basic factoring. I've always got to make sure my leading coefficient is positive, and then if there's anything in common, I always want to take out those common factors because it'll make factoring so much easier. Now, in this problem, because my leading coefficient is positive, there's nothing in common, then I always look at the last sign first. Because this tells me it's positive, that tells me they're the same of positive. So it would be plus and plus. And I can just break apart my x's, and then I have to think, what are the factors of 6 that add, because they're both the same, add to make 5. In this case, it would be 3 and 2, because 3 times 2 makes 6, but when I multiply, I would have 3x plus 2x makes 5x. So that is basic factoring. I want to point out to you that if it were plus here and this were minus, then it would be same of minus, and down here these two would change to both minus, but they still, I would owe 3x, owe 2x, and I owe 3x, I owe 2x means I owe 5x. So this would be true for this one. So I just wanted to show you how when my signs change, how that affects my answer. Now, a different type of problem is when this sign here at the end is minus, then they would be different, and these two signs, one would be positive, one would be negative, and they would subtract to make the middle term. So that's just kind of the basic reminder of factoring. Now today we're looking at advanced factoring. What does that mean? Well, so far they've gone pretty easy on you in Algebra 1 to give you always a leading coefficient of 1. Well, my friends, today is the first day of advanced factoring in Saxon. So you're going to need to know, how do I factor when my leading coefficient is not 1? I'm so glad you asked that at home, because today's your day. All right, so your book goes through and shows you when the leading coefficient is not 1. I do always want to point out to you that your leading coefficient must always be positive in order to follow these factoring rules. So your book goes through 3 different examples, and I would encourage you at home, take time to review over those examples. Pause this video and spend some time looking over that. Where does this go? Where does this go? Why did they do that? Because sometimes it's easy to hear someone do it, but actually visualizing and following through those examples are great practice for you at home. And remember, the more that you practice with factoring, the more confident you'll feel and the more easily it will come. You know, we often tease in class that sometimes we just see it faster, and that's the more practice you have, the more that you'll be able to see it more quickly. All right, so there are 2 practice problems on lesson 109. So I'd like you to work those out with me. So if you grab a notebook or some paper and work them with me, I'd like to see you practice this at home with us. All right, so we're lesson 109 and we're on practice A. Practice A says negative 11x minus 21 plus 2x squared. All right, what's unusual about this problem? Well, I hope at home you've already noticed it's not in the right order. Remember, we should have highest exponent down to constant. So I need to change up the order. 2x squared minus 11x minus 21. Now I've got it in proper order. Leading coefficient would be 2 because it's with the squared minus 11x, and lastly is my constant. Now my leading coefficient always needs to be positive. Check, we've got that. I noticed that my leading coefficient is not 1, friends. I would love for it to be 1. It's not, and I would love for 2 to evenly divide into both those so I could factor it out, but neither one are even. So I know that I'm going to have to do advanced factoring. Now I know that this is a trinomial that I can factor. Since my leading coefficient is positive, I look at my last sign first. That tells me they are different. So I know because they're different, they will subtract to make 11, since my signs are not the same. Now, this is kind of how I set it up so I can be organized in figuring out my answer. I have seen students before just write out and just keep on practicing over and over to get different numbers. And I would encourage you to be organized, because it can easily, as you're organized with it, you can easily say, oh, this factor, these don't work, and you can mark those out without having to try the same ones over and over. So I would encourage you to be organized with it. Now, my first factor is 2, and I know the only factors of 2 are 1 and 2, right? But the last factor is 21, and there are multiple things it could be. 2 is a prime number. 21 could be 1 times 21. It's not even, but 3 can go in, 3 times 7. 4, 5, and 6 do not go into 21, so it has to be one of these 2. So at least I started us off with a problem that doesn't have too many options to try. Now this is what I typically do. I do first and last. My first is 1 and 2, and my last, let's try 1 times 21. So I multiply down. 1 times 1 is 1. 21 times 2 would be 42. If I were to subtract that, that would be negative 41. And that's too high. Now if I switch it and I put 21 here and 1 here, you guys probably at home have already figured out that'd be 21 minus 2, and that would end up still being too high. 19 is too high. I need it to be 11. So I can immediately mark this one out because I know that's too high. Some of that you can do in your head and understand that that's not correct. So you might be saying, Miss Kim, why do you write it if you can do some of it in your head? It's because the organization of what number goes in what grouping symbol and what number gets what sign. I have seen students before just kind of give up and just randomly put things in. The great thing about factoring is you can always check. And remember, the inverse of factoring is foiling or distributing, right? And you would distribute those terms to both and check to see if you got the correct answer. So I love that about factoring is you can always check your answer. Don't you love that math is always fair? It's always reasonable, and you can check to see if your answer is right. All right, so what if I put 7 here and 3 here? 1 times 7 is 7. 3 times 2 is 6. So 7 minus 6 equals 1, and I need it to be 11. So I know my first factor has to be 1 and 2 because it's prime. 7 was first and it didn't work, so I'm going to write 3 times 7 this way and try it. So let's multiply down. 1 times 3 is 3. 2 times 7 is 14. 14 minus 3, or 3 minus 14, ends up being negative 11. And I do need it to be negative 11, not positive 11. So 14 has to be negative and 3 has to be positive. So what I'm going to do is go to my last terms. 7 has to be negative and 3 has to be positive, because I know my last terms were 3 and 7. 3 times 7 made 21. Positive 3 times negative 7 made negative 21. Now the tricky part is I've seen a lot of students get this wrong. I need the 7 to be multiplied by 2. If I put 2 here, they're in the same grouping symbol and they won't be multiplied when I distribute over here. So I need 2 to be multiplied by 7, so it will not be in the same grouping. So I will put 2 here with an X, and 1X would go opposite, right? It would go in the same grouping. So 3 times 1 would work here. 2 times 7 would make 14. Now, I had a student one time point this out, and I love it. Do you see that the opposites, the X, they go in the same grouping? So 1 and negative 7 go together. 2X times 3 go in the same grouping. So that was a neat way that a student pointed that out to me, and I wanted to pass that on to you so you can be checking for that at home. So always FOIL to check. And I say FOIL because that's a good reminder to me. First, outer, inner, and last. You at home know that's just distributing. 2x times x, 2x squared. 2x times negative 7 would be negative 14x. Now I'm doing the inner. 3 times x is positive 3x minus 21. These two combined and give me negative 11x. Why did I FOIL? Just to check, to verify that I got the right answer. And that's so important in algebra that you take those moments to verify, is this true? So we did advanced factoring, and that's all that they asked us to do was to factor. If they asked us to solve, we would need to set them equal to 0, break them apart, and solve it. But the book only asks us to factor there. So I want you to be on the lookout for that in case they ever say solve, you just go one step further. All right, so that is practice A. Let's jump into practice B. Again, this is advanced factoring when my leading coefficient is not 1. Let's take a look at letter B. 3x squared plus 5x minus 2. Now this time they were at least nice to us to let us start out in the right order, right? X squared, then x to the first degree, and then constant. So they at least started us out in the right order. Now we always need to be sure to check our leading coefficient is positive, and we're in good shape there. Now I always want to see if there's anything in common. 3, 5, and 2, they're all prime numbers, so nothing is in common. So I'm ready to advance factor. Now my first factor is 3, my last factor is 2, and both of these are prime. So 1 times 3 and 1 times 2. I don't have to try to figure out what factors I'm going to use, but I do have to figure out how to use them. So I always set it up this way: first, last. I'm going to do 1 times 3, and then I'm going to do 2 times 1 as my last. So let's figure out, do they add or do they subtract? So that's really important. My leading coefficient is positive, so I look at my last sign first, and this tells me they're different. So I'm going to put plus and minus. It doesn't matter at home if you put plus first or minus second. It doesn't really matter as long as one's positive and one's negative, right? Now, remember that I multiply down. 1 times 2 is 2. 3 times 1 is 3. 2 minus 3 is -1. I need it to be 5. So I know that that can't be right. So I'm going to switch the order on the second, just because I'm kind of in the habit of doing that. If I switch both, it'll still be the same. So I'm just going to switch one of them. So my last again is 1 times 2. So 1 times 1 is 1. 3 times 2 is 6. 1 minus 6 is -5. Now I need 5 to be positive. So let's think through that. If 5 is positive, then 6 would need to be positive and 1 would need to be negative. Because if I had 6, someone took 1 away, I would still have +5. So since I need positive, I know that 6 has to be positive. So I'm going to go here to my last and put positive and negative. +2, -1, because those are my last. Now remember what we said, opposites. So 2 in the same grouping will be with x or 1x. And then opposite in the same grouping with negative would be 3x. Now, at home, I have seen people who do not take the time to work this out and they just keep putting numbers in and keep checking it. That is a viable option. You can do that, but it could take a long time. That's why I love my scratch work section where I can practice and make sure I get the right facts. I've also seen students get all this practice right, and then they get panicky up here and just start throwing signs and numbers up and hope it all works out. And I do want to encourage you, there's a method to our madness, because 6 has to be positive. My last has to go with 3 times 2 to make 6. So that's why I put the plus with the 2. And I had to have 3 opposite 2 so they get multiplied to make 6x. Let's FOIL to check. First, 3x squared. Outer, plus 6x. Inner, minus 1x. Last, minus 2. And that does make 5x, so it is correct. So this is my solution. I did work right below it, but that was just to check. And I hope you're always taking time to verify, because you know what? It's so important. We can see something or read something and think, is this true? Always verify. So that's an important truth outside of even algebra. All right, so that's lesson 109. Now we're jumping to lesson 110. And lesson 110 is actually very interesting, because what they're doing is they're starting out, and we would call it a parent function. So it's taking some basic algebra shapes and saying, this is what this graph looks like. What if I shift it over? Or what if I shift it up or down? Or what if I do a negative? How would a negative affect it? How would it reflect? We understand that reflection is just a flip, right? So how does that negative affect the parent function? So some basic parent functions that your book talks about. So when it says a parent function in lesson 110, it's talking about just some basic shapes. So if I say y equals x squared, what's the graph of that? Well, that's just a basic parabola, right? Well, the book is saying to you, well, what if you had y equals -x squared? What would that look like? Well, in this graph, y equals -x squared would just take this same shape, but because it's negative, it would flip it downward. So that's what your book is wanting you to understand. How would that affect it? Now, another thing that your book shows you is it says, what if I just add 1? So what if I take, and I wish that I had a different color, because I just did those two. I'm looking to see, I apologize, I have permanent markers, but I don't think you permanently want to see this on my board, so I won't do that. But if I said x squared plus 1, well, what would that do? Well, it would actually shift it up on, if I had x squared plus 1, it would shift it up 1 on the y-axis. It would move up 1, right? Now, also in turn, if I said, what if I had y equals x squared minus 1? I bet at home you can figure that out. It's not going to flip down because the negative here was being multiplied. It flipped it. But here it would just come down 1, and it would still be the same parabola shape, just scooting down 1, right? So on page 462 of lesson 110, it shows you those parent functions and shows you what happens with a negative, what happens with a +1, with a -1. How does it shift? How does it reflect? How does it change? So it actually goes through several different parent functions. So this is what we call a parabola because it's x squared, right? It's a quadratic function. Anything raised to the second power is a quadratic. Now it gives x cubed and it shows that shape. And again, I want to point out to you, you can also plug all of this into your graphing calculator. If you don't have a graphing calculator at home, I would encourage you to download an app, or another thing you can do is actually put it on your smartphone. So I actually have an app on my smartphone, and it is called Calculator X. So it takes, and it's right here, and it actually looks a lot like a graphing calculator would look, and it can do similar things. Y equals, it has my logarithms, it has sine, cosine, tangent, so I can actually plug that in and solve. So if you don't have a graphing calculator, that's a great option. It's a free app. I just went and I looked up what was a great graphing calculator app that was free. So look for that at home. Again, this one is called Calculator X, and it's free, and it told me that it was similar to the TI-84 Plus. So that's a great graphing calculator. You can also go to websites on your computer, and I would just encourage you to type in free, because you don't want to get one of those apps that's going to cost you something. So be on the lookout for that. All right, another function that your book gives you is y equals the square root of x. Well, what does that look like? Well, when I'm graphing a square root, remember that it has a definite starting point, because I can say the square root of 0 is 0, right? So if I make a graph of this, the square root of 0 is 0. The square root of 1 is 1, right? So that's there. But then the square root of 4 is 2. So that's why it goes up very quickly, because it starts out small and then goes up. Now, how about -1? What is the square root of -1? Well, there is no number by itself that's going to equal a negative. And we'll talk about that later in Algebra 2, but there is no real number. I know you're probably thinking, uh-oh, it's more fun that's looking forward to us in Algebra 2. So we won't get into that today, but on your calculator, it actually says error, because it's not a real number. So that's why there's nothing over here in the negatives. So that's what the square root function looks like. So how about if I add 1? Well, again, the same thing, it would shift upward. So if I say y equals the square root of x plus 1, then I know that I would shift up 1. And then again, it would be the same shape, that arrow. Now, it also shows us -1. So what would it look like if I said y equals the square root of x minus 1? Well, I bet you can guess. I come down here to -1, and I do the same shape. Just I shifted from the parent function, I came down 1, right? So this went up 1, this went down 1. So those are the two differences. Now, your book also shows you the graph of the absolute value. And we studied this before in our Saxon book, but y equals the absolute value of x. What shape is that? Well, if I'm looking at a graph, it's a V shape, right? So y equals the absolute value of x. The absolute value of 0 is 0. The absolute value of 1 is 1, but also the absolute value of -1 is also 1. The absolute value of 5 is 5, but the absolute value of -5 is also 5. That's why it mirrors itself. So you can kind of see what it is here, it also is here. So it's a V-shape absolute value. So what if I said y equals the absolute value of x, you guessed it, +1? Well, if I'm following this pattern, if I'm adding 1 on the outside of the absolute value, what am I doing? Well, there you see it, it shifts up 1. So if I said +1, it's going to come up here and shift, right? So it'll be the same shape, same V, just shifted up 1, right? So that is what the beginning of lesson 110 shows us. So what does that look like? All right, so those are shifts that go upward. Now the book shows you what if I have a shift to the right or to the left. How do I get that? So we shifted up or down by just adding or subtracting one outside of it, right? But what if I wanted a shift on the x-axis? So all of these shifts have taken place on the y-axis, up. I apologize. My internet connection went out, so it started muting me. So I have no clue how long you guys have not heard me. So I apologize. But we started out just doing shifts on the y-axis, just by going up or down, right? So now we're actually looking, how can I make the shift go right or left on my x-axis? So that looks a little bit different. So how do I do that? Well, in this case, I said x squared plus 1. Right? And or x squared minus 1 made it go up or down this way. Well, in order to make it shift to the right or left, you would say y equals x plus 1 squared would actually make it shift on the x-axis this time. So on the x-axis, what it would do, you actually do the inverse. So if it's plus 1, it would actually go back 1. So on a graph, here's on the x-axis, so since it's in the parentheses with it, you do the inverse. You do what it says when it's not with a square, but here when it's in the parentheses, do the inverse. So if it says, and again, we're on page 463, so if it says plus 1, you're going to go back, and it will look like this, right? If it says, let me put a different color so that I don't confuse you. If it says y equals x minus 1 squared, the inverse of minus 1 is plus 1. So the graph is going to, oh, excuse me, it should touch that point. And it's a U, this is a parabola. Absolute value is a V, very sharp point. This is a rounded. So I'm just trying to sketch them there, right? So you'll see the difference. So I always remember, do what it says when it's outside the parentheses, right? And you do what it says on the y-axis. You do the inverse on the x-axis in the parentheses, or in the, right here, the parentheses, or in the absolute value, you would do the opposite on the x. So let's take a look at how that would look with absolute value. So if I said y equals absolute value of x minus 1. Well, the opposite of minus 1 would be plus 1. So I would move on the x-axis plus 1, and there would my v be. That sounds funny to say, doesn't it? There is my v, right? So since it's minus 1, do the inverse, plus 1 on your x-axis there. So that is very important. And your book at the bottom, page 463, shows you all those examples. So you can see it has at the bottom corner, it says absolute value of x plus 1. Well, the inverse of plus 1 is minus 1. So absolute value, it went back on the x-axis. So you can see that graph there for yourself. So they're wanting you to see how these signs affect it. Now, it also shows you a graph right here. It says y equals the absolute, or excuse me, not absolute. I just was doing absolute and I had that on my mind. So here it is, y equals the square root, and it says x minus 3. Notice here we were subtracting 1. We did what it said. We came down 1. This is the x-axis. This is the y. We came down 1 on the y, right? Well, here it's in the radical with it. So that means it's going to shift right or left, right? And since it's under the radical, we do the opposite on the x. So minus 3 would make it shift plus 3 on the x. So what would that look like? 1, 2, 3. And because it's minus 3, it's plus 3. And so the graph would go this way. All right? Notice outside the radical, do what it says on the y-axis. Under the radical, you do the opposite on the x. So I know that may take some getting used to. Miss Kim, how can I get used to that? Plug it into your graphing calculator. You can grab your calculator and put square root symbol, x plus 3, and press that graph button. Voila, there it is. So it's great practice for you. But just so you become more familiar, how does this affect this? Your book is teaching you a whole lesson that you can just know without having to press graph over and over. What if I add one here? What if I subtract one here? What if there's a negative in front of it? What if there were a negative in front of this? All right, well, I know that it would, and your book actually shows you that. I'm so glad that you all asked. So you didn't really ask, did you? It's okay. All right, but a negative is going to flip it. So it's going to do a reflection. A negative in front of an absolute value is going to flip it down. A negative we talked about up here is going to flip that down. And so your book actually shows you the reflection on page 464. And it talks about that negative value, how it flips down, how it reflects. So they even show that on page 465, the flip on the absolute value. They also showed you what if you flip it and move it up 3 spaces. So they showed that. It says combinations of shifts and reflections. So that is page 465. So example 110.4, it's negative absolute value plus 3. Well, the negative flips it, and then the plus 3, because it is not in the absolute symbol, do what it says on the y. So we shift up 3 on the y, and then it flips downward. All right, so they give you some examples there. All right, now let's take some time, to practice. So we're on lesson 110, and all that we're doing is looking how does different processes, plus, minus, and negative signs, how does that affect basic graphing? So that way you won't have to plug it into your graphing calculator every time. But I would encourage you to become more familiar with your graphing calculator and to know how that works. All right, so we're on the very bottom of page 465. One line at the very bottom. You could almost flip over and miss it, so be careful there. So we're on lesson 110, and we're doing practice A. It says sketch the graphs of the following functions. Now you can grab graph paper and be as precise as you want, but we're just going to sketch it because that's what our book asks. It says f of x, and we understand that just basically means the function of x, and we know the function of x is y, so y equals x squared plus 3. So let's talk about that. I'm looking at x squared, so immediately I have to think, if x is squared, what graph would that be? Well, I know that squared means it's a quadratic, and the graph of a quadratic is a parabola, or U-shaped. So I'm going to draw that right here just so my mind reminds myself that's what it looks like. Now, it's positive, so it opens upward. Negative, it would flip downward. Plus 3 is not in parentheses with the x squared, so I'm going to do what it says on the y. Since it's not in parentheses, there is a difference between x plus 3 squared. That would be the inverse, so it would be minus 3, and I would go back on the x-axis. But that's not what we're graphing. We're graphing this. So I do what it says on the y. 1, 2, 3. I move up, and it's opening upward. So there's my sketch, right? It mirrors itself, so that's my graph. So that's letter A. That's all I had to do for that practice. Practice letter A. All right, now let's look at practice B. What did it ask us for? It said g of x. I'm just going to write it y equals, because I know the function of it is y. Y equals, it's actually the same one that I just mentioned to you. So they're wanting to know, can you tell the difference? So I apologize, this is B. I marked it out because I wanted you to know it wasn't the same as A, obviously. So, but let's graph that. Since it is in parentheses, I do the opposite on the y. So the opposite of 3, positive 3 is negative 3. So I'm going to go back 3, and it will look like this. And it's U-shaped, not a V. So be careful of that. So it's on the x-axis. So there's a big difference between when the 3 is outside or inside. Inside, do the inverse. So that is practice B. Now let's take a look at practice C. It says h of x. So I'm going to write it up here since we started to up here. We didn't. So C, h of x, or I'm just going to write y equals negative x squared. Well, we practiced that when we were first starting out our lesson, didn't we? So that just means that it flips. So we understand a parent function would look like this, but I'm not looking at the parent function. I'm looking at the negative. So it would be the same thing, just reflected on the axis. So it would touch right here. So I apologize. They should both touch there at the origin, right? That's where they should flip at 0, 0. So letter C is just a flip. Now, the last practice problem, you have to turn the page, and it's page 466. And it could be easily missed. It's on the top, but it has some statements, and we have to decide which one is true. So let's take a look. Suppose f of x equals the absolute value of x. And they're wanting to know how the absolute value of x plus 3. Notice the plus 3 is in the absolute symbol. So since it's in the absolute symbol, just like what we practice here, since it's inside of it, we do the opposite of what it is, and we do the opposite of what it is on the x-axis. If it were outside, we would move up on the y. So be careful. So because it is inside affects right or left. So I know that it cannot be up or down. So immediately I know it cannot be 1 or 4 just based on this. So if it's plus 3, the inverse would be minus 3. It would go back on the x-axis like this one, but it would be a V shape instead of a U shape. So practice D, the answer, the only one that is true is 3. So 3 is the correct graph there. So I hope lesson 110 is something that you review and take time to go over, because I think that will be a great help to you. So lesson 110. Now we're looking at lesson 111. So if you would, turn in your books to page 468. And I hope you're practicing along with us. I hope that you're writing these things down, especially my students at home, because remember, you are doing your problems at home, but I also want to see you writing down those practice problems. Sometimes we want to tell ourselves, I'll just follow along. But, you know, our minds tend to trail off and wander. So I want to encourage you at home, make sure you're writing as I'm doing. Just like we would in class together, I want to make sure that we have those notebooks out and we're writing, because that's when the best learning takes place. I'm seeing it, I'm hearing it, and I'm doing it myself. I'm following along. So make sure you're doing that at home as well. So we're looking at conjunctions and disjunctions. So we're solving some inequality symbol. And I want to remind you that a conjunction in English class, it joins together thoughts. Well, a conjunction in algebra class joins together a graph, and it would have a beginning and an end, and it would join in the middle. A disjunction is going to go opposite, just like magnets would repel each other. The same is going to take place when we're looking at those graphs. All right, so when I'm looking at lesson 111, they're asking me to solve, and I see these inequalities and I think, oh no, these are much bigger than I've done before. How do I solve for an unknown? Friends, solve it the same as you have been solving for unknowns. It's just you have a little bit more to solve for. So let's take a moment to solve for these, okay? So everybody turn in your books to page 469, and we're going to do these two practice problems together. So it says, on my graph, it says, wow, my book is actually, the first practice problem, the first number is actually marked out a little bit. So I hope in your books at home that it's not that way for you, all right? So it looks to me to be 5 is less than or equal to x minus 2 is less than 7. And my domain is all reals. Miss Kim, why does it matter what my domain is? I'm glad you guys asked that question. So my domains, and we're on lesson 111, right? So my domain, since it's all reals, it can include decimals and fractions. if it were integers, it could only be positive or negative numbers. So that's why my domain really matters. Domain is my X values. So it's telling me what type of solutions it's looking for. So anytime it tells you a domain, it's a qualifier. It tells me what it can or cannot be, right? So I'm looking at this and I notice that I have my variable, but I have two parts here. Now we call this a conjunction because it joins, right? A disjunction would be if it has or in the middle. It's going this way or it's going this way, right? It's not meeting in the middle. So in this case, I'm solving for X and I notice that there's a process going on with X. Well, the same thing that I would do if this weren't here, I would solve, or if this weren't here, I would solve the same. So what's my whole goal in algebra? Well, my goal is to get my variable by itself. So I do the inverse operations. I'm going to add 2 to not just here and here, but to all three sides. So what is that? 7 is less than or equal to X, and this cancels out, is less than 9. So what I did there is I got my variable by itself, correct? All right, and I'm looking to make sure that I got the right problem because I cannot tell my original problem if that was a 5. I actually think that's a 6, friends. So I apologize. Those of you at home, if you're looking in your book, my book, I don't know if it's a print error or if it's just someone wrote in my book. I purchased my book used, but it seems to have a little bit extra marking there. And then I couldn't tell if the number was 5 or 6, but in looking at the solutions key, I can tell that that was a 6. In my book, part of this was marked out right here, so I couldn't tell if it was a 5 or a 6. So I apologize. So maybe some of you at home were looking at that and thinking, that's not what my problem says. So I apologize. You have the right addition. It's either my eyes or my book just has a little bit extra markings there. So it made it very difficult to be able to see that. So I apologize. But I added 2 to both sides. So I thought this was a 5, but it looks to me to be a 6. So 6 plus 2 would be 8. All right. So now when I read this, 8 is less than or equal to X is less than 9. Now I know that this is all real numbers. It can include decimals and fractions. So that means I don't have to just limit it to integers. So let's take a look on a graph. So if this were 7, 8, 9, and then, oh, I started writing 10 right on it. All right, sorry. All right. So if I'm looking at this, one way that I do is I read it backwards. X is greater than or equal to 8. I'm going to put a closed dot at 8 because X is greater than. And I know when you were little, the teacher probably taught you about alligator mouse. It would eat the bigger. So I know it can be bigger than 8. I know as you guys have got into algebra, you're too big for those alligator mouse, but maybe sometimes you can still hear your younger elementary teachers reminding you of that. Now, if I read this part, X is less than 9. So it's going to be an open dot, and I know that they're going to join. It can be 8 and anything up until 9, but not including 9, because 9 did not have the absolute, it did not have the or equal to. And looking at my solutions manual, I got that correct. So I apologize again that it was hard for me to tell if that was a 5 or a 6 from the start. So I apologize. All right, next, so we did A. Now let's take a look at B. Now this one I can read very clearly. All right, so it says, and let me get a different color so that way we can talk about the difference of these two. So B is negative X is greater than negative 3, or X is greater than or equal to 7, and this time the domain is integers. So again, that's going to qualify what the solutions can be. This time it could be decimals and fractions. This time it can only be integers. So that's really important to solve for. Now this is an or, so it's a disjunction, meaning they repel each other like magnets would that are flipped, right? So I've got to still solve and get X by itself in both places. So this has a negative with it, so I'm going to divide both sides by -1. And when I do that, I'm getting rid of the negative. But hopefully in your mind, I always teach that neon flashing lights should go off. Anytime I multiply or divide an inequality by a negative, neon flashing lights flip that symbol. So I've got to flip the symbol. X is less than +3. Or, and this one's already by itself, x is greater than or equal to 7. Let's put this on a graph. So I've got 2, 3, 4, 5, 6, 7, and 8. All right. So if x is less than 3, it cannot include 3. That would be an open dot. Since I'm only writing integers that it can be, then I would have 1 here and 0 here, right? So it could be 2. I'm not sure if you can see my marks there. And it would keep on going in this direction off my board, right? I don't want to write on my wall. I accidentally did earlier. So let's not do that again, right? That's not good. Don't do that at your house, right? Now, x is greater than or equal to 7. So in this case, I can include 7, whereas over here, I could not include 3 because it was not or equal to it. So x is greater than or equal to 7, so it can be 8, it can be 9, and then we're going to put an arrow this way so we can let ourselves know it can go this direction or this direction, but it's not the middle, right? It's a disjunction. They're not joined with each other. So that is practice B. So lesson 111, and we did practice A, and then we did practice B, so you could see the difference. This domain was real, so it could, that's why we put the line in the middle, because it could be 8.72456, right? It can be anything right in the middle. Here, because my domain limited it, my domain, my x values, can only be an integer, 7, 8, 9, 10. It can't be 8.5. It can't be even 3 because it's not or equal to. It can't be 2.5. It can't be 1 1/3. It can't be any of those things because my domain limits it. All right? So I hope that makes sense to you on lesson 111. Now the last lesson that we're going over today in Algebra 1 is lesson 112. So you guys have done a great job. We've plugged through 3 lessons so far. We've got 1 lesson left to go. And we've had so much algebra fun today. I just love factoring. And I love foiling. I just think those are our key algebra concepts. Well, friends, we've got another key algebra concept that we're going over for this week as well. So on lesson 112, we're looking at more radicals. And we know that a radical symbol is just a square root symbol. And your book is wanting you to know, how do I work with radicals and multiplying? You know, sometimes those things can be tricky if we don't learn how to easily navigate through those. So your book is reminding you. We've gone through some radicals before. So it says, what if I had the square root of 3 times 5 plus the square root of 12? Now I've seen students try to combine those and say, well, that's 5 square root of 12. Be very careful. It's not, because it's not being multiplied. This is 2 different terms. The whole number 5 plus the square root of 12. So if I'm taking a look at this, I have to distribute this radical to both. So what would that be? 5 square root of 3 plus, and notice both of these are radicals. There is no whole number. So since there is no whole number, then I know it's the square root of 3 times 12. Now some people go ahead and multiply that out, but I feel like it's easier if you're breaking it down, so I'm not going to multiply it together. I know at home you know 3 times 12 is 36. But I can go ahead and bring this down. This is 3, and this would be 3 times 4. Well, I know that what I'm looking for in square roots or radicals, I'm looking for perfect square roots. And 12 is not a perfect square root, 3 is not a perfect square root, but when multiplied together, the square root of 36, it is a perfect square root. Now, maybe you didn't catch that. Well, if I factor it down, I always tell my students I'm looking for matches for perfect squares. I know that 3 times 3 is 9. The square root of 9 is 3. So I can take that out of the square root symbol. Then I also notice that 2 times 2 is 4. The square root of 4 is 2. So I can take that out of the square root symbol. So my final answer, simplified, would be 5 square root of 3 plus 6, because 3 times 2 is 6. So I'm really excited to see that because they're separate, and I know that I can solve that. So that's on page 471, your very first example there. So let's take some time to do the practice. So all that we have left, friends, are 4 practice problems at the very bottom of our lesson. This is actually a very short lesson. Sometimes Saxon will have multiple pages and multiple examples. They did give us several examples, and I would encourage you at home to take time to do that. But all we have left to do is 4 practice problems, and they just want us to navigate through how does that square root symbol apply. So we've got 4 practice problems left to do. So the first one is 5 plus the square root of 2, and that is a binomial, two terms, and then times 3 plus the square root of 8. So I've got 2 terms and 2 terms. What do? I've got to distribute them, right? So first, 5 times 3 is 15, outer, plus 5 square root of 8, inner, plus 3 square root of 2. Notice that my 3 was a whole number, my square root of 2 is a radical, so they're multiplied together, but one's a whole, one's a radical. You can't say square root of 6, it's 3 whole times the square root of 2. Now my last would be plus, and both of them are radicals, so it's 2 times 8. Both are under the radical symbol, right? Now I can factor this down, that's 4 times 2, bring down my 2, here's a match, and then 4 is a perfect square root, that's a match. So I have 1 match of 2, another match of 2, 2 times 2 is 4. So this has worked down to simplified plus 4, right? Now here, 2 is prime, so I can't simplify that any further. 4 times 2 is 8. 2 times 2 is a perfect square root. That's 1 match. I take it out. Since I already had 5 on the outside, 5 times this 2 that got taken out would be 10. 10, and then I still have 1 square root left, so that's 2. Now, notice that this is 10 square root of 2. This is 3 square root of 2. So 10 square root of 2 plus 3 square root of 2 is the same if I said 10x plus 3x. All right, because these are both the same terms, I would just say 10 plus 3 is 13 square root of 2, right? I'm just adding together because they're both in the same terms. And then I've got 15. So my answer would be, oh, and I forgot I had another whole number. So 15 plus 4 would be 19, right? So my final answer for lesson 112 would be 19 plus 13 square root of 2. 19 plus 13 square root of 2. Notice I cannot combine these terms. Now at home, I hope you're saying because they're not like terms, right? Just like if I said 19 plus 13x. Even though 19 and 13 are numbers, because I've got the square root of 2 with 13, it's got to be multiplied by that before they can be added, all right? So they're not like terms. So that's my, I did 2 binomial radicals, right? So I was multiplying those out. So that was practice A. Now I'm on practice B. So practice B is another one, all right? So I've got 2 plus the square root of 5, and I am multiplying it times 4 minus 3 square root of 5. All right, again, what do? I'm going to FOIL first. 2 times 4 is 8. This time I've got a minus symbol, so it's going to be minus 2 times 3 is 6, because those are my whole numbers, square root of 5. My inner is going to be plus 4 square root of 5. Because there's no sign in front of 4, it's an understood plus. And my last, there's 1 negative sign, minus 3, and it's square root of 5 times 5. Both are under the radical symbol, so both stay. But in this case, because there's a match, 5 times 5 is 25. The square root of 25 is a perfect square, right? That's why I told you before why I call them matches, is I'm looking for those perfect squares. So since it is a perfect square, I can take out my 5. So negative 3 times 5 is negative 15. All right, now these are like terms. So it's the same as saying negative 6x plus 4x. All right, so I would just say I owe 6 of them. I have 4 of them. So I owe 2 of them, right? And then I have 8. so I'm adding 8 to it. So it means -7 minus 2 square root of 5. I owe more than I have, right, friends? So that is practice letter B, -7 minus 2 square root of 5. So we're halfway done with our last lesson. So we're just foiling with radicals. What does that look like? All right, we're on practice C. Now I've got square root of 2 plus square root of 5, and it is squared. Now that looks funny. Maybe we might say, well, Miss Kim, can I just add those? Square root of 2 plus square root of 5 is square root of 7? I'm glad you asked that, but no, it's the same thing as saying x plus y. They're not like terms. The radicals have to be the same to add. Like in the last problem, square root, I can't remember what the question was. It was something square root of 5 and something else square root of 5. So since they were in the same terms, we could solve those. This one's not. So an easier way to look at it would be to expand this out so you can visualize it. So when it's saying squared, it's saying multiply it by itself. So we're going to FOIL it just like we had been. First, square root of 2 times square root of 2. Well, 2 times 2 would be 4. There is a match, so I would just take it out. So it's 2 whole. Square root of 2 times square root of 2 is square root of 4. Square root of 4 is 2, right? There's a match there, right? Now, we did first. Now we're doing outer. So that'd be 2 times 5. Both of those are under the radical symbol, so it would be square root of 10, right? Now, I just did O. Now I'm doing the inner terms. Square root of 5 times 2 again is square root of 5 times square root of 2 is square root of 10. And then last, I'm doing my last term. Square root of 5 times square root of 5. They're both square root of 5. 5 times 5 is 25. The square root of 25 is 5. Or you can remember what I said. If you're multiplying and there's a match, just take that match out, plus 5. These are both whole numbers. 5 plus 2 is 7. These are both like terms. I have one of these and I have one of these, therefore I have 2 of these, right? It is not prime, but it is 5 and 2, so it cannot be simplified any further. So this is my final answer, 7 plus 2 square root of 10. Now, there is one more that we need to do, and it's letter D. So we've done C, and we're on the last one, letter D. All right, we've done C, and we're on the last letter D. This one could be a little bit tricky because, it's letter D, and it says square root of 2, and then x is outside the square root, plus square root of 7y squared. Now, it could be easy to mix this one up, but I do want to be on the lookout for this to make sure that I'm solving it right. So I'm going to rewrite it square root of 2x plus square root of 7y. Because it's squared, I'm multiplying it by itself. And I think sometimes just writing it out gives you opportunity to see it a little bit better. So first, square root of 2 times 2, it's a match. Take the 2 out, x times x, x squared. Outer, square root of 2 times 7 is square root of 14xy. Inner, 7 times 2 again. Don't forget you're adding in between each one. Plus 7 times 2 again is 14, but don't carry that square root symbol too far because x and y are both outside, right? And last, 7, square root of 7 times square root of 7. If I multiply it together, it's square root of 49, or I can just see 7 and 7 have a match, so I take it out, 7y squared. Combine like terms, so that would end up being 2 of these terms. 14 is 7 times 2, and it's not a perfect square, so I can't go any further with it. And these are not like terms, so I cannot combine them together. X squared and y squared are not like terms. So this line, I'm going to take this part out where I was showing you that it cannot be simplified. And that is my final answer for problem D. You might say at home, Miss Kim, that's a lot more work. Yes, we're doing a little bit more work with radicals because it's preparing you. We're almost finished with Saxon Algebra 1, and this is our stepping stone to get us ready for Saxon Algebra 2. I appreciate your hard work, and I'm really thankful for the time we had today to go through lessons 109 all the way through lessons 112. So we'll see you next week. Thank you so much.